Hello everyone and welcome to our today's class. It is the first lesson on the topic force. Now I'm sure you have encountered situations in life whereby you've seen people maybe pushing a car from a muddy area, or even pulling a cart carrying some luggage, or even a trolley from a supermarket. Now whenever a body is pushed or pulled, then we define that one as force. We define that as force. So force simply refers to a push or a pull of an object. Now the SI unit for force is actually Newton. So in abbreviation it is a capital N, Newton. So it was given the units of Newton because it was discovered by a scientist called Isaac Newton, who was actually seated under a mango tree, and he saw a mango falling to the ground. So he was asking himself, why didn't the mango move upwards? It means there is a force that is pulling it downwards. Yeah. Then there are four effects of force on a body. Let's start with the first one. That if a body is at rest, assume that my hand is the body at rest. When I act a force on it, actually the body starts moving. So that is the first effect of force on a body. So the first effect of a force on a body is that it starts motion of a stationary object. It starts motion of a stationary object. Another way of putting that point is that a force can also increase the speed of a moving object. So if my hand was the moving object, then I came and applied a force on it, it actually increases the speed of a moving object. Another way of saying the same point is that a force actually accelerates an object. It accelerates an object. The second effect of force is that a force actually stops motion. It stops motion. If my hand was the body moving in this direction, then I apply a force on it this way, it actually stops moving. It stops moving. So a force stops motion. Or another way of putting this point is that a force can also can decrease the speed of a moving object. Or you can also say that a force decelerates an object. It decelerates an object. Now the third effect of force is that if the body, that is my hand, is moving this direction, then I act a force on it, it actually changes the direction of a moving object. So that is the third point, that force actually changes the direction of a moving object. Now the fourth effect of force on a body is that when I'm holding an object like this one, it is roughly in a rectangular shape, but if I apply force on it, actually it becomes shapeless. It becomes shapeless. That is this way. So a force can actually change the shape of an object. It can change the shape of an object. Another way of placing that point is that a force distorts an object. It distorts an object. Having looked at the four effects of force, we can also look at actually the force itself. Now force can be of different magnitude. We can have large forces and we can also have small forces. That is, for example, the force that you will require to, for example, hold this pen is too much smaller than the force that you will require to push a car from a muddy area. So because force exists in different sizes, that is, we can have a large force and a small force, therefore we say that a force has size, or what we call the magnitude. Now a force actually is represented by a straight line with an arrow. Now the straight line, the length of the straight line represents the size or the magnitude of that force, while the arrow actually represents the direction of that particular force. So a quantity that has both magnitude or size and direction, we actually refer to it as a vector quantity. Therefore we can conclude that a force is a vector quantity. Now we can also look at different types of forces. We can look at different types of forces. So there are several types of forces, but I'll highlight a few. One is what we have, what we call the gravitational force. We have the upthrust force. We have surface tension. We have tension force. We have cohesive and adhesive forces. We have electrostatic force. We also have what we call, we can have actually magnetic force. Yeah, those are just a few types of forces. Now let's start discussing these forces. Now our first force that we are going to discuss is what we call the gravitational force. Now this was, as I said earlier, this was discovered by Isaac Newton. Isaac Newton was seated under a mango tree. Then he saw actually a mango falling from the tree and coming towards the ground. So he was asking himself, why didn't this mango actually move upwards? It means there is a force that is pulling this particular mango downwards. So that force is what we are calling the gravitational force. So if you are asked to define what we mean by gravitational force, actually this is a force that pulls an object towards the center of the Earth's surface. A force that pulls objects towards the center of the Earth's surface. Now the pull of gravity on a body is referred to as the weight of that body. The pull of gravity on a body is referred to as the weight of that body. Now remember, weight actually depends on gravity. So and different planets have different gravitational pull. For example, the Earth has a gravitational pull of 9.8 Newton per kilogram, which is approximately 10 Newton per kilogram. You go to a different planet, for example Jupiter or Mars, you will find their gravitational pull is actually maybe higher or even lower than the Earth. For example, the gravitational pull for the moon is usually around 6.67 Newton per kilogram, which is slightly lower than the gravity on Earth. So that means if you take a body, the same body, you weigh a body on Earth, it will actually, its weight will be more than when you weigh the same object on moon. Why? Because the gravitational force for the moon is actually low. So there is usually this question that is asked, that you give a reason why the weight of an object varies from place to place or from one planet to planet. So the reason is because weight actually depends on gravitational force, which varies from one planet to another. Now we can also discuss another type of force, which we are calling the tension force. So tension, actually, this is a force within a spring or even a wire, actually a force acting on the spring when it is either pulled from both ends or when it is compressed. Yeah, that is what we call the tension force. Now if the force that causes a body to be compressed is what we call the compressional forces. Now there are different types of materials. There are these materials when they are either stretched or compressed, they don't break. Yeah, there are materials that when you stretch they can actually break, but others when you stretch they just get stretched but they don't break. Such materials we call them elastic materials. So elastic materials, these are materials that do not break when they are either stretched or when they are compressed. They do not break. Now we look at our last type of force, which we are calling actually the upthrust force. Now you remember that whenever you place an object within in a liquid, for example water, actually that object weighs less than its actual weight. When you weigh an object in water, for example when you weigh an object in air, the weight that you will obtain on your spring, it will be more than the weight of the same object but immersed in water. That means that within that water there is an upward force that is acting on that particular body that makes it appear less to have minimum weight or low weight. Now this force is what we are calling the upthrust force. So if you are asked to define upthrust force, you say this is an upward force that acts on a body immersed in a fluid. When we talk of a fluid, we mean a fluid can either be a gas, for example air, or a liquid. So upthrust force is an upward force that acts on a body immersed in a fluid. Now there are usually calculations involving upthrust. So you need to know that upthrust of a body is equals to the weight of that body in air minus the weight of that body when immersed or when submerged in a liquid. We can have an example here. If a body weighs 20 Newton in air and weighs 15 Newton when immersed in water, what will be the upthrust force acting on it? So upthrust will be weight in air minus weight when immersed in water. So that will be 20 Newton minus 15 Newton. So the weight of that object, the upthrust force acting on that object, will be equal to 5 Newton. That is 20 minus 15. Now when we'll be discussing flotation and sinking in Form 4, that is when you will understand more about the upthrust force, where we'll be discussing things to deal with the Archimedes principle. We also have the law of flotation, Now we have come to the end of our topic of our lesson today. So, but I cannot end the lesson without giving you a very interesting story. So today's story is of a great man who was actually a king. He was called Alexander the Great. I'm sure you've heard of that name, Alexander the Great. So when this person was just about to die, one day he actually fell very sick, and he realized that he was just about to die. So on his way to home, actually he had his soldiers, or what we call the generals. So he had 3 wishes that he wanted his soldiers to fulfill on his when he dies, actually, or during his burial. Now the 3 wishes were: 1, that his coffin must be carried by his own physician, that is the best doctors in the world. 2, that the way leading to his graveyard, or the way leading to his grave, must be filled with jewelry, gold, and expensive stones that he had kept in his treasure. And the final wish was that while he is being buried, his hands must be left dangling or hanging out the coffin. Now the generals actually agreed with those wishes, but one of the generals asked the Alexander the Great, why do you decide to give us these strange wishes? Could you give a reason for each wish, why you have wished so? So Alexander the Great actually started explaining his wishes. 1, he said that the first wish, that his coffin must be carried by the best doctors in the world, or his physician. This was to show that in the times of death, not even the best doctors in the world can actually heal you. So that shows that life is actually valuable. So you should treasure small moments in life. The second wish, that his the path leading to his graveyard, should be filled with jewelry and very expensive materials that he had acquired during his life, was to show that in the times of death, actually, the things that we acquire in life do not matter. Yeah? The things that we treasure in life, that is possessions. For example, big cars, we can have maybe gold, they do not matter in the times of death. Yeah. Then the third wish, that his hand must be left dangling in the coffin, was to show that to show the world that he came empty to this world and he will live empty. So I think we can derive very great lessons of life from the story of such a great person. Now, I'm adding this. Remember this. Money can buy you a house, but not a home. Money can buy you a bed, but not sleep. Money can earn you a title, but not respect. So while you're living in this life, actually make sure you have an impact on someone, because the impact you have on people around you, that is the thing that remains when you are actually gone, or what we call the legacy. So I'm also challenging you with this statement that don't just aspire to make a living, aspire to make a difference. Thank you guys. This is a Kind Tuition Academy. Subscribe on YouTube. Thank you.